Let's go through LeetCode 3031. Minimal time to revert word to initial state. For this question, it give us a word, string word, and also an integer k. So we can perform any of the following operation. That is, remove the first k characters of the word, or at any second you can so this is one operation, right? So we'll say remove the first k characters and add any k characters to the end of the word. So it asks the minimal time you need to revert to the original word. So let's say this will always have solutions, right? So because we can append because we can append anything for this word, right? So if we remove k, and append a k, right? So the worst case is that we remove for example, to all of the word, right? So we just make sure the word we append is the same from here to the end. That will be the same from of this word, right? So the worst case, it will have results. So we'll say if so in this case, it will be n divided by k or n divided by k plus 1, right? So that's the worst case. So depend on whether this can multiply k, right? So this one is actually n minus 1 divided by k plus 1, right? The thing is that for this kind of operation, right, if we can find, for example, there is an I, we matches this part to the end, this kind of length, the same as this, right? Then, and also if this I is case multiplication, then we'll see that will be the earliest time we can do the manipulations to revert to the initial state, right? So the thing is that what we do is that we can, for every I, we calculate what is the length it will match the prefix, right? So if we have I plus the I equals n, that means this part to the end will match this part, right? That means, and also if this is I is a case manipulation, then we just return this I multiplied by k, right? So in this case, we can use the algorithm. The Z algorithm is that we have a string S, right? So if the length is n, we are going to create a Z array. It is an integer array, right? For every index I, it represents for the character I, how much it will match from the prefix of this string, right? So for example, there is A, B, right? So there is also a for example, A, B, C. There is A, B, D here, right? So I say there is A, B match, right? So I'll say this one, this A, well, this kind of ZI will have match 3 characters, will be 3, right? And for this A from the beginning, it matches 1 because after that it is B, right? So that will be 1. And B does not match the status, so that will be 0, right? So we create a Z array, which will be the maximal match length from the prefix of this string. So we call this Z array. The advantages of the Z algorithm is that instead of do the brute force, and for every matching part, for example, we call this Z box. For this Z box, it have the same character with its this string's prefix. So if we want to calculate this Z, for example, this is ZG, right? We can find the corresponding Z K here, right? And if this is ZK plus this this index hasn't exist the right bond of this string, right? So we'll say this ZJ will be equal to ZK. Otherwise, if this ZK exists this original, this part, or we cannot determine, right? So we need to try to compare the index after the right bond 1 by 1, right? So if it exits this kind of Z box, we need to compare this character and this character, right? So that we call this the Z box, right? So the right boundary is keeping expanding, and if we are matching, right, we keeping our left bond equals to I, right? Because this one will never use old one. So because we are going to I will always moving forward. So we'll find this kind of Z box window. Its left index and right index will never go back. So this is like a slide window. So using the Z box, Z algorithm to do the string matching, the time complexity will be O(n). So after this analysis, let's begin to write code for this. So we'll say we have character array equals word which array, right? And we'll have int n equals array dot length, and we are going to have left equal to right. This is the left boundary of left index of Z box, and the right that will be the right index of Z box. In this case, we are going to create a Z array, right? Because new int n. So what we do is that for int I equals 1, I smaller than n, I plus plus, right? So I say this kind of zi, we know this one not being a negative one, so will be max at least to be 0, right? And because the right boundary, out of the right boundary, we will never calculate yet. We didn't do any comparison yet. So what we do is that we are going to have math.main z I minus left, and also we cannot exit the right boundary, that is I, this is minus I plus 1, right? This is the length, right? And then if index, we're trying to see from the right the box right boundary, and also this kind of string, prefix string, right? We're trying to compare this character whether they equal or not, right? So that we can extend our Z box. So what we do is that while I plus zi smaller than n. Let's say and array zi equals array I plus zi, right? In this case, we'll have left equals I, right equals I plus zi, right? And then we'll also need to extend our zi plus, right? So here, after we calculate this is the array, what we need to do is that if we have I mod k equals to 0, right? That means in our index, it is we can cut in sometimes to this I, right? And I plus the I equals n. That means the rest part it matches the prefix of the string. So we just return I divided by k, right? Otherwise, if we didn't find a match, what we do is that we just return. Instead, we compare whether this can is divisible by k or not. We can do n minus 1 divided by k and plus 1, right? So this will be the dbox solution, and we can write this as Python as well. So what we do is we're going to have n left right equals length word 0, right? And what we do is that for I in range 1 to n, let's say z, we need to create the z array, right? Z equals this one multiplied by n. Z I equals max 0 min z I minus left and right minus I plus 1, right? And we'll say while I plus zi smaller than n, we'll say and, right? The should be word zi equals word I plus zi. In this case, we need to update out left or right, right? Left will be I, right will be I plus zi. And we also have the I will extend by 1 if there is one more match, right? So in this case, what we do is that we already calculated the zi, right? So we have if I mod k equals 0, right? Means for this I, it is the case multiplications, right? We can do case operations to this I, and also I plus the I equals n. That means from this I, we match to the end, we match the prefix of the string, right? Then we just return I divided by k, right? Of course, you can have this as well, but because this that is the same, right? Because the mod by k equals to 0. Otherwise, what we do is that we return I minus 1 mod by k plus 1, right? For here, we need to have a double slash, okay? Because we want to get its integer, right? This should be princess. That's how also this one to be this, right? Because we want to return int. If we use this one, you see it will be 2.0. So let's also use double slash, right? So doing like this will be better. The one if this one mass word left right for in max a I minus left. So if this one smaller than I and word zi equals word I plus this one. So and equal this one I plus the I. So why this is 1, but we expect 2. This is the n minus 1. Okay. The time complexity is O n